Hello everyone, welcome back to our channel. If you're new here, don't forget to hit that subscribe button and share our content with your friends. Today, we're diving into a captivating subject that's literally reshaping our world. Our focus is the continent of Africa, or to be more precise, the fact that it's gradually splitting into two separate land masses. Yes, you heard that right. This isn't a work of science fiction, but an ongoing geological event that's been unfolding for millions of years. It's a phenomenon that helps us understand the dynamic nature of our planet and the colossal forces that shape it. It's about the East African Rift, a divergent tectonic plate boundary, where the African plate is splitting into the Somali and the Nubian plates. This grand spectacle of nature is not only intriguing, but also holds great relevance to our understanding of Earth's geological history. In today's video, buckle up for a journey through time as we explore the fascinating phenomenon of Africa's ongoing continental split. The story of Africa's split begins millions of years ago, but it's not ancient history. This geological drama is still unfolding today. Picture this: our Earth, around 22 to 25 million years ago, a significant event is taking place on the African continent. The birth of the East African Rift, also known as EAR, signals the beginning of a transformation that will shape the face of the continent for millions of years to come. The EAR is an active continental rift zone, a place where the crust of the Earth is being pulled apart. This rift zone is not just a simple crack in the ground. It stretches over thousands of kilometers, a vast network of faults and valleys that extends from the Red Sea in the north to Mozambique in the south. But what's causing this massive geographical shift? The answer lies in tectonic plates. The Earth's crust is made up of several large pieces like a giant jigsaw puzzle. These pieces, called plates, are not static. They move, albeit very slowly, driven by the convective forces in the Earth's mantle below them. In East Africa, the African plate is splitting into two separate pieces, the Somali plate and the Nubian plate. As these plates drift apart, they create the East African Rift. Imagine pulling apart a piece of bread. As you apply force, the bread begins to tear, creating a rift. This is essentially what's happening to Africa, except on a much larger scale and over millions of years. The tearing of the African plate has resulted in numerous geological features, such as active and dormant volcanoes, continental flood basalts, and the formation of the eastern and western rift valleys. The evolution of the ER, whether it's driven by mantle plumes or super plumes, is still a topic of debate among scientists. Regardless of the cause, the result is clear. Africa is splitting, and this split is still ongoing. It's a slow process, with the plates moving apart at a rate of 6 to 7 millimeters per year. As we speak, Africa is slowly tearing itself apart, at a rate of 6 to 7 millimeters per year. But how exactly is a continent splitting apart? Let's delve into the science behind this remarkable process. At the heart of this phenomenon are tectonic plates, enormous pieces of the Earth's lithosphere that fit together like a global puzzle. These plates aren't static, they're always shifting and sliding past each other. Now, imagine two of these colossal plates, the Somali plate and the Nubian plate, which are part of the larger African plate, slowly drifting apart. This is precisely what's happening in East Africa right now. This divergence creates what we call a rift, a thinning and stretching region where the crust and upper mantle break apart. The East African Rift, or EAR, is one of the most dramatic examples of this process in action. It's a divergent tectonic plate boundary, which means the plates are moving away from each other. The ER isn't just a simple line on a map though. It's a complex system made up of three microplates, each with its own distinct movement and characteristics. These are the Victoria, Rovuma, and Somali microplates. Together, they stretch over thousands of kilometers from the Afar Triple Junction in the north all the way down to Mozambique in the south. As these microplates move, the Earth's crust stretches and thins until it eventually breaks, forming a rift valley. These valleys, like the Eastern Rift Valley and the Western Rift Valley, are marked by volcanic activity, continental flood basalts, and both active and dormant volcanoes. So, what we're seeing in East Africa is essentially a slow-motion continental breakup. Over millions of years, the tectonic forces at work are gradually tearing the continent apart. The process may be slow, almost imperceptible in human timescales, but the evidence is all around us in the form of rift valleys, volcanic activity, and the gradual widening of the ER. In essence, the continent is breaking up, much like a gigantic jigsaw puzzle coming apart. Now that we understand the how, let's look at the so what. What does this mean for Africa and the world? The East African Rift is not just a geologic wonder, but it's also a hotbed of seismic activity. This rift is teeming with both active and dormant volcanoes, making it a crucial area for studying volcanic and seismic phenomena. The presence of these volcanoes suggests a continually evolving and changing landscape. This constant transformation often results in the formation of continental flood basalts, massive lava flows that cover large areas of the Earth's surface. But what's captivating about these volcanic activities is not just the seismic spectacle they put on. They also contribute significantly to the region's mineral wealth. Over millions of years, volcanic processes have churned out an array of valuable minerals, making the rift zone a geological treasure trove. These minerals are not just geologically interesting, they're economically vital. The East African Rift is rich in significant mineral resources, including rare earth elements, gold and gemstones. These resources are of considerable economic interest, both for the nations of East Africa and for the global commodities market. The exploitation of these resources can potentially drive economic growth in the region, creating jobs and boosting income for millions. However, the extraction of these resources must be balanced with environmental considerations. The rift is home to unique ecosystems, and any mining or extraction activities must be carried out responsibly to preserve these delicate environments. Let's not forget, the East African Rift is also home to some of the world's most iconic landscapes and wildlife. The rift's lakes and mountains are not just scenic, they're crucial habitats for a wide range of species. Any changes to this environment could have profound implications for biodiversity. So while the split might seem like a slow catastrophe, it also reveals a wealth of natural resources. The East African Rift is a story of change and transformation, a tale of destruction and creation. It's a reminder that our planet is an ever-evolving stage where the forces of nature continuously shape and reshape the world we live in. While we've established that the split is happening, what does the future hold? Will we see a new ocean forming in our lifetimes? The potential of the East African Rift to separate Eastern Africa from the mainland is a fascinating concept. However, it's important to note that this separation process is happening at a geological pace, which is significantly slower than our human timescale. In fact, this process could take tens of millions of years. To put this into perspective, the rift began developing around 22 to 25 million years ago, and it has not yet completed its course. The rate of separation is estimated to be around 6 to 7 millimeters per year. When we consider these numbers, it becomes clear that the transformation of the African continent is a slow and steady process, one that requires immense patience to observe. But let's imagine, just for a moment, that we could fast forward into the future. What would we see? Well, the Somali Plate, which includes parts of Kenya, Ethiopia, and all of Somalia, would have drifted away from the Nubian Plate, creating a new oceanic basin in the space left behind. This new ocean would be a testimony to the dynamic nature of our planet and the continuous evolution of its landscapes. In the future, the map of Africa could look very different. Where there was once a vast continent, there may be a new ocean, separating Eastern Africa from the mainland. The eastern part of Africa could become a large island continent, similar to Australia today. This future scenario is not just a figment of our imaginations, but a possibility based on scientific research and geological evidence. However, as we mentioned earlier, this process will unfold over millions of years, far beyond our human lifespan. So, we might not witness a new ocean in our lifetime, but future generations could potentially see a very different map of Africa. We've journeyed through millions of years today, exploring a fascinating geological phenomenon that's still in progress. We've delved into the history of the East African Rift, a tectonic wonder that has been shaping the face of our planet for 20 to 25 million years. We've investigated the process of how the African plate is splitting into the Somali and the Nubian plates, a process that's happening right under our feet at a rate of 6 to 7 millimeters per year. We've also examined the implications this has on our world, including the significant mineral resources the rift has to offer. And we've peered into the future, contemplating what the continent might look like millions of years from now. The story of the Earth is ever-changing, and the East African Rift is a dramatic chapter in that ongoing narrative. It's a testament to the dynamic, evolving nature of our planet. As we wrap up, let's remember to stay awed by the intricate workings of our world. Thank you for joining us on this geological adventure. Don't forget to subscribe and share our content with your friends. Until next time, stay curious.